Today I want to talk about electrical terminology, and we're going to start with voltage. So voltage is known as electromotive force. And often when we use the Ohm's law triangle, you'll see E over I R. Now it can be written V over I R as well. They're interchangeable at this point, but voltage is the electromotive force that creates pressure within a circuit. So the term that we use could be V for voltage, again, E, electromotive force, and it represents pressure. In fact, if you draw a battery with a plus post and a minus post, if you put your meter on here, the potential difference between, if it's a fully charged battery, is 12.6. So the potential difference or voltage of that battery is 12.6. Current is the excess of electrons or the deficiency of electrons that create flow in a circuit. So electrons, when we're talking about current, it's amperage, and when we're using Ohm's law, we use I. We use I. But we better finish that. The amount of current is 6.24 times 10 to the 18th power, which works out to 6.24 billion electrons, which equals 1 amp. So if you have that many electrons flowing through a conductor, measured in 1 second, that's how many electrons are flowing. So that's our current. And finally, resistance is the last integer on the triangle for Ohm's law, and it represents the opposition to flow. So resistance is R. Sometimes you'll see it as the, oops, I can do better than that. Sometimes you'll see it as the omega, and sometimes you'll see it as R. There we go. So, oh, you can see it as ohms too. I knew there was one more. There we go. So that's resistance. Now resistance in a wire is affected by the cross-sectional area, so how big the wire is, how long the wire is, and what it's made of. So some wire, copper, gold, silver, make very good conductors, where others, steel isn't as good, and lead isn't good at all. So that is the three terms. Voltage, the electrical pressure or electromotive force. Current is the flow of electrons, and resistance is the resistance to flow. I hope this helps.